So as we're doing this problem, the only way that you know to take a derivative right now is using the limit definition. So what we're going to have to do, we're going to have to find the derivative, and usually what we do is we find the derivative and plug in an x value of a point, and that will give us the slope of a tangent line. Well, I don't have a point. We have no x y value given to us. Okay, so I'm not gonna set the derivative equal to the x, or I'm not gonna plug the x value into the derivative because I wasn't given an x value. What I'm going to do once I find the derivative is set the derivative equal to -1, because that's what I want the slope to be. And I'm gonna solve once I plug the once I set the derivative equal to -1. I'm gonna solve for x, and so how many ever x values that gives me, that's how many different equations there are. But first, let's find the derivative. And again, the only way I know to take a derivative at this point is to evaluate the limit as h approaches 0 of f of x plus h minus f of x all over h. So if the function is 9 divided by x minus 5, f of x plus h is 9 divided by, forget my limit notation, x plus h minus 5. Then we gotta say minus f of x all over h. So if I evaluate it right now, it would be an indeterminate form. So I'm going to try to make it look different. I'm going to find a common denominator in the denominator in the top. And that will be x plus h minus 5 times x minus 5. So that means instead of just 9 on the fraction, in the numerator of the fraction to the left, it would have to be 9 times x minus 5. And instead of just 9 here, its denominator was missing an x plus h minus 5. So I'll have to say 9 times x plus h minus 5. To get, I'm just going to go ahead and actually call this, so I don't have to write it down so many times. 9x minus 45 minus 9x minus 9h plus 45. And so the 45 cancels, the 9x's, wait, this was a 9h right here. The 9x's cancels. And so we just have the limit as h approaches 0 of -9h divided by x plus h minus 5 times x minus 5. It's all divided by h, right? Well, instead of dividing by h, I'm going to multiply by the reciprocal. That's the same as dividing. I'm going to get rid of this here, if I can get a good enough eraser to do it. And when you do that, these h's cancel, and you can use direct substitution, no more limit notation, and get -9 over x minus 5 times x minus 5, which is -9 over x minus 5 squared. Anyway, this is your derivative. Now, most of the time, again, we would have an x value, and we would plug that into the derivative, and it would give us a slope. But that's not what we have this time. We have a slope, and we want an x value. So set the slope of -1 equal to -9 over x minus 5 squared. Now, right here, we need to cross multiply. -1 times x minus 5 squared is -x minus 5 squared equals -9. Well, now I'm going to divide both sides by -1 and isolate the x minus 5 squared. And so you can take the square root of both sides to get the to get rid of the squared, and that will leave us with x minus 5 equals plus or minus the square root of 9, which is 3. Okay, so what you want to do is set the two different equations up. X minus 5 equals 3 and x minus 5 equals -3. And just solve those really quickly. Get 8 equals x, and that 2 equals x. So the slope of the tangent line is equal to -1 at two different x values, at 8 and at 2. But it didn't just ask us where the slope of the tangent line was -1. It asked us to write the equation of the tangent line where the slope is -1. So you need to use the point slope formula twice. And we got some stuff that we can plug in, but we don't have this y value right here for either one of them. But you could go ahead and plug in the slope at -1 and then x minus 8 and -1 and x minus 2. But we need to find that y value for when x is 8 and when x is 2. We need to find those respective y values, and you can do that by plugging it into the original. So 9 divided by 8 minus 5, so 9 divided by 3 equals 3. So that's the 0.83. And then y equals 9 divided by, let's see, 2. 2 minus 5, which is -3, 9. So 2, -3 is that point. So now we can go plug in those y values. So when it was 2, it was a y value of -3. When it was 8, it was a y value of +3. So let's finish this out. Y minus 3 equals -x plus 8. You can then add your 3 to both sides and get 11 for one equation. And the other becomes y plus 3. And let me go ahead and distribute that -1. -x plus 2 equals y plus 3. Subtract 3 from both sides. So y equals -x minus 1. Those are your two tangent lines when the slope is -1.